Good morning, students. In today's session, we will see how to conduct Swinburne test on DC shunt machine. The purpose of conducting Swinburne test on DC shunt machine is to estimate the constant losses, and with the help of the constant losses, we are able to predetermine the efficiency of the shunt machine when it is going to act like a generator and when it is going to act like a motor. And the other names for Swinburne test is no load test or predetermination test. So with the help of this test, we can estimate the efficiency of the machine from no load to full load without actually applying the load. So with the help of no load input itself, we are able to estimate the efficiency at different load conditions. Okay, and the circuit arrangement for conducting the Swinburne test is as shown in this top figure. So here the DC shunt machine is provided with DC electrical supply, and in order to measure the load current under no load condition, that is no load current, we are using one ammeter, and in order to measure the input voltage, we are using one voltmeter, and the motor is started with the help of a 3-point starter, and in order to control the speed of the motor at the beginning, we are using one rheostat in the field circuit. With the help of this rheostat, by flux control method, we can vary the speed, that is the rated speed of the motor can be obtained. And here, in addition to the measuring equipment, we are using one SPST switch. The SPST switch is used to protect the ammeter from high starting currents. Actually, the starter is used for limiting the starting currents. So even though the starter is going to limit the starting current of the motor to less than its rated current, but here, as we are conducting under no load conditions, the ammeter range that we are going to use is within the range of no load current. Okay, so that we will see in the practical connections. So this is the motor that we are going to use. This is the nameplate details of the motor that we are going to use for conducting the test. The shunt motor with 5 HP rating with 19 amps rating, and this is the circuit connections for conducting the test. So we will start from supply terminals plus minus, then from plus it is connected to the starter L terminal through a single pole single throw switch. After that, from armature terminal A to armature terminal of starter A to armature A, then AA to negative, that completes the armature connection. Coming to the field connection, from starter F terminal to the rheostat, from rheostat output terminal to the ammeter, field ammeter, and then ammeter negative terminal to the field winding Z, then ZZ to negative, and the voltmeter is connected across the supply mains. The voltmeter is connected across the supply mains. So these are the connections that we are going to make. So here, if you observe, the full load current is 19 amps, but as we are conducting the test under no load conditions, the motor is going to draw only no load current. It will be around 10%, so around 2 amps we are going to get. So for this purpose, we are connected only a ammeter with a range of 5 amperes. So the starter is going to limit the current less than 19 amps, but there may be possibility that the current may be more than 5 at the time of starting. So in order to protect the ammeter from high currents at the time of starting, we have connected one SPST switch across the ammeter. So at the time of starting, the SPST switch should be closed and the rheostat should be kept at minimum resistance position, and we have to take care that the brake drum the belt around that brake drum should be loosened. So here we are not used any belt for conducting the Swinburne test, so there is no problem. The motor is operating under no load conditions. So with this circuit arrangement, we are going to start the experiment. So for conducting the experiment, first we need to close the DPST switch, and then we are going to give the DC supply. Then with the help of 3-point starter, we have to start. After that, with the help we have to check the speed. The speed is 1500 RPM rated speed, then it's okay. Otherwise, we have to bring the motor speed to 1500 RPM with the help of field rheostat. By varying the resistance in the field circuit, we have to bring the motor speed to 1500 RPM. When the motor is running at 1500 RPM, that is at rated operating conditions, we have to open this SPST switch and we have to note down the meter readings. So this is the process. So let's start the experiment. First, we have to close the DPST switch. Then with the help of starter, we need to start the motor. Once the motor is started, we have to check for the speed. So it is already 1500. Then there is no need to vary the field resistor. Okay. Then we are going to open the SPST switch and we are going to note down the readings of field current, load current and supply voltage. So based upon the connections that we are given, we have to use the multiplication factors, and with the help of meter readings, we have to take the readings in the tabular column. So with the help of these readings, we can calculate the armature current, and after that we can calculate the constant losses, and after calculating the constant losses, we need to calculate the efficiency when the machine is acting as a generator and when it is acting as a motor. We need to complete these two tables that we will see in the calculation part, we will see in other video. And one more thing is, we need to get RA value for getting the constant losses. The constant loss are obtained by subtracting the copper losses from entire input. Subtracting the copper losses from the entire input. For calculating the constant losses, we need to know the value of RA. So that armature measurement can be done by using voltmeter and ammeter method. Okay, that we will see in another video. Okay. So after getting the constant losses, we need to find out the generator efficiencies at different operating conditions and motor efficiencies at different operating conditions. So when the shunt machine is acting as a motor and when it is acting as a generator, we need to find out the efficiency from no load to full load conditions at different load conditions. So that calculation part we will see in another video. Thank you.